Mixture and alligation. Section 1. In here we'll be finding average, and it tells us how much to mix two or more things together to get one thing with desired price. Let's use an example. Suppose this dot costs 2 rupees and this 6 rupees. And now let me ask you a question: how to mix them together such that each dot costs 3 rupees? Got the answer? If not, here it is. So let's take one dot of 2 rupees and one dot of 4 rupees and combine them, which should indeed give you each dot costing 3 rupees, as the average of 2 and 6 is. And that's mixture and alligation. Now let's use another example, because this example I think it would not even count. So second example, this time the dot prices are 2 and 10, and we gotta find how to mix them, or more precisely in what ratio we gotta mix them to get dots with say 5 rupees. Go on, give it a try. Done? Here is the answer. We will generalize what we have done in the first example. We had two categories of dots and we took some number of dots from each category, and they don't have to be the same number. Then after we have averaged them to get the desired price. Now here, as we look at this equation, we find we know the desired price and the prices of each dots. All we got left is to find x over y, the mixing ratio, and to get it we simply rearrange the equation. To sum it up, we have managed to gather two numbers, one for each category, to show how to mix them together such that on an average we get the desired price. Now let's move to section 2, problem 1. In what ratio must water be mixed with milk to gain 20% by selling the mixture at cost price? Let's suppose the cost price of milk is X per liter, and he mentions that there has to be a gain of 20% by selling this milk. That makes selling price 20% more than that of cost price, right? Now this is not an option, because he says selling price should be equal to cost price, which you might wonder how, but he also gives away the way by saying you can mix water. So now we reduce this cost price of milk by adding in water, which is free. And exactly how much do we reduce? We reduce it by the amount that gives us a gain of 20%. So 20% of CP is now the desired price with 0 and X to be mixed, and we get the ratio to be that. Problem 2. The milk and water in two vessels A and B are in the ratio 4:3 and 2:3 respectively. In what ratio the liquids in both the vessels be mixed to obtain a new mixture in vessel C containing half milk and half water? Step 1. Laying out the picture. There are two vessels with a mixture of milk and water, one with the ratio 4:3 and the other with the ratio 2:3. Or in the other way of saying is 4/7 of the milk and 3/7 of the water is contained in one vessel, whereas 2/5 of milk and 3/5 of water is contained in other vessel. Step 2. Find the relation and solve. Now we got to mix them in such a way that their average equals 1/2 of milk and 1/2 of water, and to do that we use the mixing ratio 7:5. So go on, give it a try. And if you're new to this series, please look in the description. There will be a playlist containing all the videos in this series for you to follow along.